currently pursuing BE in Electronics and Communication in STCE. I am from third semester A section, Department Electronics and Communication. Today my subject is Network Analysis and the topic is Explain the classification of electrical networks. Explain the classification of electrical networks. Electrical networks can be classified based on their configuration, components, and nature of operation. Here is an overview of the classification. Based on configuration, linear networks, the circuit parameters resistance, inductance, capacitance remains constant irrespective of the applied voltage or current. Examples: resistor circuits, RL and RC circuits. Non-linear networks, circuit parameters change with variations in voltage or current. For examples, circuits with diodes or transistors. Based on type of elements, active network contain energy sources, voltage or current sources that can supply power to the circuits. Examples: circuits with batteries or generators. Passive networks do not contain any active sources and rely on external energy. Examples: pure resistor, inductor, capacitor, RLC networks. Based on signal type, AC networks operate with alternating current AC sources. Examples: AC power distribution systems. DC network operates with direct current DC sources. Examples: circuits with batteries or DC power supplies. Based on interconnection, series network components are connected end to end and the same current flows through all the components. Parallel network components are connected across the same voltage source and the current is divided among them. Combinational networks have both series and parallel elements. Based on response, transist networks study the circuit's behavior when it changes from one steady state to another, typically during switching operations. Steady state networks examine the circuit's behavior under constant conditions. Based on energy storage, unilateral networks allow the flow of current or voltage in only one direction. For example, diode circuits. Bilateral networks allow current or voltage to flow in both directions. For example, resistor, inductor, or capacitor based networks. Based on functionality, power network used for power generation, transmission, and distribution. Examples: national grid systems, substations. Communication networks used for transmitting and processing information like signals. Examples: telecommunication circuits, antenna networks. Let us see about the based on lumped or distributed parameters. Lumped parameter and distributed parameter. Lumped parameter. Network assumes all components, resistors, capacitor, inductors are concentrated at discrete points in the circuit. Examples: simple RLC circuits. Distributed parameter networks considers that components parameters, resistance, inductance, capacitance are distributed continuously along the circuits. For example, transmission lines, waveguides. Based on topology, open circuit, a network where the circuit path is broken and no current flows. Closed circuit, a network with a complete path allowing current to flow. Mesh network contain loops or closed paths where currents can be circulate. Node network focus on the interconnection points of different branches in the circuit. Based on the presence of feedback, open loop and closed loop. Let us see about the open loop. Networks operates without feedback. The output does not influence the input. Examples: basic amplifiers. Closed loop. Networks incorporates feedbacks where the output is used to adjust the input for stability or control. Examples: control systems, feedback amplifiers. Let us move on to the based on stability. Stable network circuits that return to their normal operation after disturbances. Unstable network circuits that fail to return to their normal operations after disturbances, often leading to oscillations or damage. Key concepts related to networks. Superposition theorem used to analyze linear networks with multiple sources by considering the each effect of each source separately. Thevenin on Norton Thevenin and Norton's theorem simplify complex networks into equivalent circuits for easier analysis. Network graphics representation of electrical networks using nodes and branches, aiding in topological analysis. Resonance Resonance, a condition in RLC networks where the inductive reactance equals the capacitive reactance, leading to maximum current. Let us see about the applications of electrical networks. Power systems, electronics, control systems, signal processing, and transportations. Power systems, efficient distribution and transmission of electricity. Electronics, designing circuits in devices like computers, TVs, and smartphones. Control systems, used in automation and robotics. Signal processing, filters, amplifiers, and communication networks. Transportation, electric vehicle systems and railway networks. Thank you for watching.